And there's also DSI. You'll see there's a couple DSI people back there. So they operate the telescope. And it's designed for 20-year lifetimes, and we've just started. We have more flights and longer flights. The operation is in Palmdale, California, just north of LA. And the Science Center is in NASA Ames, it's just south of San Francisco. So we got two NASA centers working together on this very important project. We basically float the whole telescope. It's 10 metric tons, and it just floats there. There are motors then that move it around. There are gyroscopes that keep it accurately pointed. The SP didn't fly that long because it wasn't all that profitable, I think. And so it actually doesn't have that many hours on it relative to and they refurbished it, so it's in really good shape. Yeah. So I think it could go on longer than 20 years easily. Also, this time of year, the water vapor is actually very low. So the flying conditions are quite good. Definitely one of the big pluses for SOFIA is the ability to move put one instrument on, take the science, then take it off.
And now we are evacuating our cryostats because our detectors are superconductive detectors. They have to be cooled down to minus 270 degrees C. And later this afternoon we will fill the cryostats with liquid nitrogen and liquid helium to get this low temperature to get our detectors operational.
Christchurch is certainly a big part of the answer, both because you have really good weather here this time of year and you have some really nice objects in the sky to study. The whole Milky Way in the south, where stars are forming like nowhere else. There's also the Magellanic Clouds that are forming stars different because they have a whole different metallicity. That's how many atoms of heavy oxygen and nitrogen are in between the stars. And people are extremely interested in this question for questions about how did the early universe actually all get started.